With India's growing population and rapid increase of urbanization, the pace of augmenting municipal infrastructure of cities has been a challenge. The quantum of waste we generate as citizens and its disposal in a streamlined and scientific manner has suffered. The consequences are health problems, polluted air and water contamination. The impetus given by the Swachh Bharat mission of the Government of India since it was launched on October 2, 2014 has put the focus on effectively cleaning our urban spaces. But huge challenges remain. So in this episode of Science for a Self-Reliant India, we look at how India's urban spaces can be cleaned up. And what better way to start than at India's largest landfill, the Ghazipur waste site. Here, the East Delhi Municipal Corporation is working to reduce the size of Delhi's infamous waste mountain, which has been accumulating since 1984. For EDMC, it is a difficult and challenging task, but one that is faced by many cities across India. We look at how the waste at Ghazipur is being re-excavated and segregated by trommel machines for various processes, like using waste for generating electricity at the waste-to-energy plant, utilizing construction debris for making paver blocks and construction materials, using wet waste for compost, so that the waste reaching the landfill is reduced and the material is processed and recycled more effectively. All this and much more only on India Science. The 70-acre Ghazipur site on the outskirts of Delhi is one of the largest landfill sites in Asia. It receives about 2,500 to 3,000 metric tons of solid waste from India's national capital daily. Even though the Ghazipur site reached its peak carrying capacity in 2002, hundreds of trucks from various municipalities arrive to dump waste every day. The reason is simple. Delhi, like many large cities of the world, is running out of space to dispose its own garbage. There are also legacy issues of previous decades. An estimated 140 lakh tons of waste has collected in Ghazipur since 1984, when the site was first opened. The collapse of the Ghazipur landfill, leading to the death of 2 people. The Supreme Court of India also took cognizance of this incident and directed the East Delhi Municipal Corporation and other municipalities of Delhi to find solutions to Delhi's growing waste problem. What was needed, particularly in Ghazipur, were large-scale interventions to process the waste arriving at Ghazipur more efficiently and also to reduce the existing waste mountain. The EDMC turned to the trommel machine cum ballistic separators, which is a mechanical screening machine which offers effective recycling and waste material screening. This machine is based on a rotating drum technique which separates solid waste from inert materials. Since 2018, the EDMC has installed 20 trommel machines in Ghazipur alone. These machines process an average of 3,000 metric tons of waste per day.
One of the dreams for almost everyone in EDMC and also for people outside EDMC within Delhi is reduction of the height of Ghazipur dump site. So we have been doing a lot of work towards that end, and as of now the height has been reduced by 12 meters. And during last 4 months before the monsoon, we have done very speedily, and more than 3 lakh metric ton of the waste has been processed and sent for fruitful use. And also we have reduced the fresh waste which is reaching the SLF site.
The cylindrical drum of a trommel screen consists of holes of many different sizes on its surface and moves in a circular motion. As the drum rotates, the screen allows small particles and inert waste to be separated out, forming a pile, while the waste that is bigger than the size of the hole is retained at the back of the cylinder. This machine can be operated for both dry and wet waste. Trommel machines are highly effective and useful machines which play an important role in solid waste management, as waste recycling and waste reuse is possible only when it is properly segregated. These machines are available in a variety of sizes with varied diameters and lengths, depending on the capacity of waste segregation, so they can be used to segregate waste in smaller municipalities as well. The trommel machine segregates waste into three major categories: construction and demolition waste, plastic and combustible waste for use as fuel, and enriched soil and inert waste. Around 15% of the waste is used as refuse-derived fuel or RDF and sent to the energy plant in Ghazipur for producing electricity. Nearly 20% of the waste is sent to the construction and demolition waste plants of EDMC for making bricks, tiles and sand. While the soil-like material, which comprises of over half of the waste collected, is used for the filling of low-lying areas. It is also sent to NTPC's Eco Park, where so far 8,000 tons of waste has been transported. The remaining waste is sent to parks of EDMC. The EDMC has also signed a Memorandum of Understanding with the National Highways Authority of India for the use of inert material in road construction.
And at the same time, the problem lies not in processing but the disposal of the byproduct which we are getting, where to dispose of the inert. And there has been apprehension among the user agencies regarding the inert, the quality of inert, how to use it, whether it will be feasible for their products or not. So we are also taking up a pilot road project in West Vinod Nagar for showing that this inert can be useful for compaction of concrete also.
The garbage dumped at the Ghazipur site over the years has attained a height of over 65 meters, and no further space is available on the ground for its horizontal expansion. But with the installation of trommel machines, the height of this waste has been reduced by as much as 12 meters at certain places, and efforts are now being made to increase the number of trommels to further reduce the height of the dump. EDMC is also planning to process 100% of the old waste lying in the Ghazipur landfill site by the end of 2024. The 5 municipal corporations of Delhi, which comprise of over 280 municipal wards, generate approximately 14,000 tons of solid waste in a single day. The per capita generation of waste is about 600 grams per day, one of the highest in India. Of this, the MCD collects over 10,500 tons of garbage every day. The city has a processing capacity of 6,100 tons, which includes 2 incineration plants and 2 centralized composting units. So about 4,600 tons has to be disposed of in the 3 main dumping sites of Delhi: Okhla, Bhalaswa and Ghazipur. And this is a major issue. After all, landfill sites have finite space, and they also exact a heavy toll on the environment by causing air and water pollution. They are also a major health hazard for communities living around the area. Under the Solid Waste Management Bylaws 2018 for the National Capital Region, decentralized waste processing like biomethanization, composting and methods of biostabilization or biodegradable waste has been prioritized to bring down the volume of waste that ends up in the landfills. The objective is to reduce transportation costs as well as the related environmental impact of dumping waste in landfills. For waste-to-energy plants, segregation of waste has been made mandatory.
What happens when people don't source segregate? Your paper, your plastic gets contaminated, and then sometimes your waste picker does not spend enough time taking out resources. So all of it gets sent to the landfill then. So you've lost a lot of resource which could have been extracted, and the value that could have come out of the waste does not happen. And then all of it adds to the load that the landfill anyways have. Delhi has 3 landfills functional. One is your Bhalaswad, Ghazipur, all of these, and they're already past their peak capacity. And Ghazipur incident was one wherein the landfill was, over capacity. That's the reason why it fell, people died. And this is one of the biggest reasons why we should look at source segregation.
MCD and other agencies that work at the municipal level like the NDMC and the Cantonment Board also need to ensure that horticultural, park and garden waste is processed at the source where it is generated. So what is compost? Well, it is a mixture that consists largely of decayed organic matter which is essentially used to fertilize the soil. It is commonly prepared by decomposing plant and food waste and recycling organic materials. Composts commonly contain about 2% of nitrogen, 0.5 to 1% of phosphorus, and about 2% of potassium. Compost is useful for improving soil fertility in gardens, horticulture, urban agriculture, and farming. It also improves the soil structure and provides a wide range of nutrients for plants and adds beneficial microbes to the soil. Modern composting was systematized by an English botanist, Sir Albert Howard, who incidentally was based in India in the early 20th century. Howard spent almost 30 years experimenting with organic gardening and farming. He developed a pit composting system as early as 1931 and published it in a short publication called The Waste Products of Agriculture, Their Utilization as Humus, written by Albert Howard and Yashwant D. Wadi. It was further developed by Acharya and Subramaniam, and the methods are conventionally referred as Indore and Bangalore methods of composting. Composting is aerobic decomposition of organic matter, involving microbial decomposition of waste in the presence of oxygen. Organic or biodegradable waste is converted to a soil-like substance or compost, which is used as manure for the improvement of soil quality. The importance of composting cannot be overstated as the process reduces organic waste from our homes by 20 to 30% of its initial weight and of course converts it into a useful product. The composting process involves 4 main components: organic matter, moisture, oxygen and bacteria. Moisture is important to support the composting process. If the pile is too dry, the water materials will decompose very slowly, and oxygen is needed to support the breakdown of plant materials by the bacteria. Bacteria and other microorganisms are the actual actors in the composting process. By supplying organic matter, water and oxygen, the already present bacteria breaks down the organic matter into useful compost. The amount of time needed to produce compost depends on various factors such as the size of the compost pile, the types of material to be composted, the surface area of the materials, and the number of times the pile is turned. In general, the average composter turns the pile every 4 to 5 weeks. With frequent churning, compost can be ready in about 3 months, depending of course on the time of the year. In cold winter, the activity of the bacteria slows down, which also slows the composting process. If the municipal waste is composted at the community level, that is composted at the source or near the source of generation, there would be a significant reduction in the amount of waste to be transported for treatment or to the landfill. In developing countries like India, where 40 to 60% of the waste consists of organic matter, waste can be efficiently managed by establishing decentralized composting plants across the cities where the waste is collected and then composted.
If you're not recycling, if you're not segregating your waste, it's very difficult to take out any resources from the waste that is there. All of it gets sent to the landfill. On the landfill, it just decomposes and creates methane and creates greenhouse effect. Methane is the reason why you have landfill fires. So all the resource that could have been taken out gets wasted there. Or everything that's there, paper, plastic, everything gets burned, and then it's a waste of resource there.
Under the encouragement and support of the Swachh Bharat mission, municipalities across the country are focusing on composting as an important component of the solid waste management strategy. It's a process that can also be adopted by resident welfare associations and even at the household level. Another decentralized process which works effectively to reduce the waste load for landfills and generates useful renewable energy is biomethanization. This technique generates useful biogas while at the same time considerably reduces the quantity of waste to be thrown in the landfills. Since ancient times, combustible gas has been known to seep from geological fissures in certain areas of the world. However, the experiments of Italian physicist and chemist Alessandro Volta with combustible air obtained from sediments and marshy places created widespread interest and laid the scientific foundation for the study of the biological formation of methane gas. Interestingly, Volta is the pioneer of electricity and power and is credited as the inventor of the electric battery and the discoverer of methane. Biomethanation is a process by which organic material is microbiologically converted under anaerobic conditions to biogas. Three main physiological groups of microorganisms are involved: fermenting bacteria, organic acid oxidizing bacteria, and methogenic archaea. These microorganisms degrade organic matter to methane and carbon dioxide. Biomethanation technology has emerged as a viable option for managing organic solid waste generated in the urban areas. Besides reducing the waste load by about 50%, biomethanation generates biogas, compost derivatives, and nutrient recovery. Biogas is a product of anaerobic biological process called methanogenesis, which takes place in the absence of oxygen. This process is also referred to as biomethanization. The biogas, which is a byproduct of biomethanization, is a mixture of methane and carbon dioxide as well as parts of oxygen, nitrogen, and some other trace gases. The standard applications of biogas include heating and power generation. To see how this gas is generated, we travel to one such plant in Shastri Park, New Delhi. In this plant, the wet waste is converted into biogas by the biomethanization process, and the biogas is then used as a fuel to generate electricity. This plant has a 5-ton per day capacity and generates 450 kilowatts of electricity per day, out of which 200 kilowatts of electricity is used in the daily operation of the plant and the rest is transferred to the grid.
We have set up two 5-ton plants of biomethanization for converting the organic waste into electricity, and also we have 10 plants of 1-ton capacity. Apart from this, there is already a project of 100-ton per day of the organic waste, especially the cow dung, is in progress, and we hope that that will also be set up soon. Apart from this, 1200 ton of biomethanization plant is also in planning stage, and again we hope that by end of next year it will be operational.
So let's see how this plant works. The municipal tipper vans bring the wet waste in the plant. The wet waste is then segregated and plastic and other items are removed. This segregated waste is then fed into a crusher machine which converts the feed into a thick slurry. This slurry is then fed into the digester where it is stored at around 40 degrees Celsius. After 20 days, the biogas starts to release from the feed. This biogas is then transferred and stored in a special container known as a balloon. Biogas also contains sulfur along with methane and carbon dioxide. For removing sulfur, the biogas is passed through a filter called scrubber which absorbs the sulfur, and the remaining methane and carbon dioxide is transferred into the generator for the generation of electricity. The remaining slurry can be used as compost after about 20 days. Composting and biomethanization techniques, because of their methane utilization capability, can take the advantage of carbon finance because such processes not only reduce the weight of solid waste but also save the environment by diverting methane, which is a greenhouse gas. By preventing biodegradable or organic waste from getting into the landfill, composting plants significantly reduce methane gas emissions. And this reduction can be claimed as emission reductions and it can be sold to the carbon fund. Everything required to run a good waste management system is available right here in India. The science, technology, technical skill sets and human resources to run the waste processing chain. So we are completely self-reliant. The Swachh Bharat mission of the Government of India has also provided technical know-how, financial assistance and infrastructure. But large-scale participation and awareness of us, the citizens who produce this waste, is required so that the waste generated at source can be effectively recycled and reused, and only the minimal is sent to the landfills. Municipalities need to put in place large-scale scientific solutions and processes to treat our waste using environmentally sustainable processes. Waste processing is in fact considered a job generator, and financial experts and economists have calculated that waste processing and disposal leads to increased GDP as jobs are generated, and the environmental price we pay for poor sanitation reduces over time. As the saying goes, a Swachh Bharat is a Swasth Bharat, leading to India's Atmanirbharta, both socially and economically.